We're back. What we're going to look at now for the CP Physics class, Unit 1, Math Tools, are unit conversions. If you're coming from chemistry within the Trinity schools, someone might have called this train track method or fence post or something like that. But really, it's just a use of dimensional analysis, converting from one unit to another. And we need to do this sometimes when we just got like strange things like minutes to seconds to hours and days, or you're talking about miles per hour and like they get into kilometers per second. And how do you convert these things? So that's what we're going to look at here. If you liked the fence post or train track method or whatever you learned in prior years, like feel free to use that. It's totally cool. It's totally right. I'm just going to show you how I do things. So if you like this better, use this instead. Doesn't really matter though. Okay. So let's pretend for an instant that we know that we can walk at a speed of about 3 miles per hour. Okay. Normally backpacking hikers hike somewhere between 2 and 3 miles per hour. If you've got a really heavy load on, you're closer to 2. But let's say you're doing 3 miles per hour. Okay. But your pal in Europe wants to know how fast that is in meters per second, because we're using the miles per hour and they're using the proper metric unit of meters per seconds. So how could we convert these factors? Well, there's 2 unit factors that we need, conversion factors here. The first is that 1 mile equals 1,610 meters. We just need to know that. That is a conversion factor. It's something that we need to know to relate one unit to the next. And with that conversion factor, we can begin our calculation. The other conversion factor we're going to need, though, because we're in hours and we're looking to get this into seconds, is we need to know how many seconds are in an hour. Well, we know that there's 60 minutes in an hour and 60 seconds in each minute. So if you wanted to physically count those, every minute you'd count 60 seconds and you do that 60 times. So 60 times 60 brings us to 3,600 seconds. And that's a pretty easy calculation to do, 60 times 60, because we can say 6 times 6 is 36, and then we'll just add these extra zeros on. Boop, boop, boom, 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 boom. So 1 hour is 3,600 seconds. And these are our 2 conversion factors that we need here in order to complete this problem. So if you're doing this in a train track method or a fence post, whatever you want to call it, what you would do here is you would write out the 3 miles per hour first. So let's just start with that. 3, and then something that is a real sticking point for me, whenever I type these, I put this slash mark here to show a division. But really what you should be doing is you should be writing these one number over the other, or the units over each other. So this is 3 miles per hour. Okay, really go horizontal there. Don't write this as 3 miles per hour. You will mess it up. I'll show you how you'll mess it up in a second. But 3 miles per hour here. Okay, now if you're doing like a fence post, train track thing, we need to get rid of the hours. And right now the hours are in the bottom, the denominator. So that means to get rid of them, we need to put an hour up top, because now what will happen is these will wipe each other from the face of the earth. And what we can say here is that in 1 hour, there are, well, how many seconds? Because we need seconds in the denominator here. Well, there's 3,600 seconds. So now I've got 3 miles over 36,000 or 3,600 seconds. I don't want miles though, I need meters. So how would we do that? Well, if I've got miles in the numerator, then that means that I should be putting miles in the denominator. So 1 mile, and that will cause our miles to cancel out or divide out. And in 1 mile, how many meters are there? There's 1,610 meters. This will mean that our only units we have left are meters over seconds, which is what we're looking for. Now the only thing we have to do is we simply take all of the values in the numerator, the top, and we multiply them together. So 3 times 1 is 3. 3 times 1610 is, I don't know, calculator's going to solve that for me. This hour in the denominator here, there is an implicit 1 in front of it, because 3 over 1 is 3. So 1 times 3,600 is 3,600. 3,600 times 1 is 3,600. So this is going to be, in the denominator, 3,600 seconds. In our numerator, we're going to have to do 3 times 1610, which is 4,830. And this is in meters, so I've got my units now, meters and seconds. And then now I just have to do this division here. And I don't have a calculator run through that. So 4830 divided by 3600, that's going to equal 1.34 meters per seconds. And that's it. That's how you do some unit conversions or dimensional analysis. Okay? Nothing crazy about it. If you want to call it fence post, train track, whatever, that's what we're doing. Okay? To give a quick brief summary on why I hate it when people write like this is because you're going to get it wrong when you write like that. When people write like this, you know, they'll put like 3 miles per hour. What they'll then do is they'll try to train track it and they'll go, oh, I've got hours up top. I'll put hours in the bottom like this. And then they'll put the 3600 seconds here. And they'll say, look, these cancel out. But if you look at this, what we did previously, that's wrong. The hours were in the denominator. When people write them side by side like this, they think everything's up top and they flip something. So don't do this. This is a no-no. Don't do that right there. So angry when that happens. Really write things out one over the other. I know if you're using lined paper, you know, it looks nicer if you put the slash, but really, like, we can regrow the trees. Put one over the other, use the paper space, get the problem right, know what you're doing, okay? Just one more thing I'd like to talk about in this video are some metric system relationships. The metric system actually was genius whenever it was kind of developed in France. And there are some really cool relationships that exist because of its development in a very mathematical and precise way. If we take a look at a liter, right here, a liter by definition is a volume enclosed by a cube, which is 10 centimeters on a side. So this cube here is 10 by 10 by 10, and that cube that is created there is by definition 1 liter, okay? Now, something that's 10 by 10 by 10 is 10 times 10 times 10, 10 times 10 is 100, 100 times 10 is 1,000. So in this cube, there are 1,000 centimeter cube in there, okay? So a little centimeter cube is this little guy right here, and there are 1,000 of them in a liter. If we take a look at this cube of water here, well, a cube of a liter, and we make it a exact cube of water, H2O. 1 liter of water, by definition, has a mass of 1 kilogram, and that's because we chose the density of water to be 1. That was our sticking point when we did this. So a liter of water has exactly 1 kilogram worth of mass, which if you wanted the English unit of it, that's about 2.2 pounds. But if you want to do that conversion, or just, I know a lot of people are more familiar with pounds here in America. So if you had something in kilos, basically multiply it by 2 in a little bit, and you'll figure out how many pounds that is. So if you were like, hey, I'm 100 kilos, well, you're around 200 pounds, really you're about 220, okay? Because of the cool relationship of 1,000 cubic centimeters in the liter, this means that a milliliter of water is equivalent to a gram. And it means that a milliliter of H2O, which is 1 gram, is actually equal to 1 cubic centimeter, okay? So sometimes if you're watching like a medical doctor show, they'll say I need 50 cc's of something stat, right? And when they talk about cc's, what they're talking about are cubic centimeters, because even though it's a cubic centimeter, it is the same concept as a milliliter of something. So it's kind of a neat thing there. And last but not least, if for some crazy reason you had a meter by a meter by a meter of water, that would equal 1 metric ton, or 1,000 kilograms. And if you're like, who's walking around with meters of water? Well, if you've ever filled up a hot tub is something like, I don't know, maybe 6 to 8 cubic meters, which means that your hot tub is something like 6 to 8,000 kilograms. And if you multiply that by 2, your hot tub is something like 12,000 to 16,000 pounds. Which is why whenever you put in a hot tub, you should put it on a reinforced surface, like 6 inches of concrete instead of 4. And if you're deciding to put a hot tub on the 2nd floor of your house, you better reinforce that flooring, or else you're going to get an entire hot tub falling from the 2nd floor. Okay? So these are just some of the neat kind of metric prefixes and metric system units and relationships that I wanted to talk about. But these are just kind of neat things on why the metric system is so useful as opposed to what we use in the States as an imperial system. Okay, but with that, this is finished. Take it easy. Make sure you're using your train tracks, fence posts, whatever it is for your dimensional analysis, and write things over one another.